In this video, we're going to look at the factors that affect the solubility and the rate of dissolving of various chemicals in various solvents. So in this section, we're going to look at some factors that affect the solubility of different solutes in solvents. And so this is just a reminder that when we talk about solubility, it's how much solute dissolves in 100 grams of a given solvent at a specific temperature. So there are really two major factors that affect the solubility. Previously, we looked at the first one, which was the temperature, in which we saw that solids were generally more soluble at higher temperature and gases were less soluble, always at higher temperature. So now we're going to see how we can affect how much dissolves by affecting the pressure. Pressure only has an effect on gases. It does not affect any of the solids or liquids. The easiest place to observe this is with a 2-liter bottle. When you have a 2-liter bottle of soda, you'll notice that they have a lot of pressure. As you try to squeeze on it, it's very hard when it's filled with the soda and it's sealed. But what happens when you release that pressure, you take the lid off of the soda bottle, what do you notice? You should notice that a whole bunch of bubbles start to come out, and because they're being released from the solution, when you don't have the pressure to push them back in, they're released, and that means that the solubility is decreased. As you increase the pressure, you can force those bubbles back in, but when you lower the pressure, the bubbles come back out of the liquid. So overall, we know that an increase in pressure increases the solubility of a gas. So you probably already knew this, and you use this probably regularly if you have soda. What are the two things that we do to save our soda from going flat? Normally, we say put the lid back on, and then we put it back in the refrigerator. Putting the lid on allows it to continue to build up pressure until it no longer loses gas, and by putting it in the refrigerator at the colder temperature, more of that gas stays dissolved, and so it doesn't go flat as easily. And the last one is listed in your book as something that affects the solubility, but I feel that it is an inaccurate statement to say that it affects the solubility. And the reason I feel that is because when we define the solubility of a substance, we say that there's a certain amount of solute, let's say KNO3, that dissolves in 100 grams of the solvent, in this case maybe water. So if we know that ratio, we know we have a specific solute and a specific solvent. As soon as I change one of those, I am definitely going to get a different solubility because it's a different substance. That does not change the solubility of the solute and solvent system that I'm talking about. So again, the book says that this is a separate thing. It is a true fact that the nature of the solute and the solvent does affect how much is soluble, but we can't change that as a part of the definition of the solubility of that substance. Basically, what we do know is that like dissolves like, and that is something that I do want you to know. So the term like dissolve like means that things that are similar to each other will dissolve in each other. And I'll give you more information about that when we talk about how things dissolve and you start memorizing the solubility rules. So we looked at what affected the solubility of a substance. Now let's look at the factors that affect the rate of dissolving. The rate of dissolving is talking about how fast something dissolves, not how much. Solubility says how much. There are three major factors that we're going to look at. They are particle size, temperature, and stirring. We'll focus on particle size first. Here I have a sugar cube and granulated sugar, and I want to know which one will dissolve faster in a big glass of iced tea. Number 1, the sugar cube, or number 2, the granulated sugar. You should see that number 2, the granulated sugar, will dissolve faster. That's because of its smaller particle size. So smaller size means faster dissolving. And we can see that there's a larger surface area so that the solvent is in more contact with the solute, and that allows it to dissolve faster due to the increased number of interactions. Now let's look at the temperature. Okay, here I have a big glass of iced tea, number 3, and number 4 I have a big cup of hot tea, and here we want to know which one will dissolve the cube of sugar faster. So you probably already know this from your daily life, but the hot water will dissolve the sugar cube faster. And this is partly because of the kinetic theory of molecules. Recall that at higher temperatures, the particles are moving faster. Because they're moving faster, there are more interactions, or colliding with each other more often, and so we see that these particles will dissolve faster because there are more collisions. And finally, let's look at how stirring affects the rate of dissolving. You probably already know, if you've ever added sugar to your tea, that if you stir it, it will dissolve faster. So solutes do dissolve faster when they are stirred, and that is because as we stir, we make the particles move faster, and therefore there are more collisions. The more collisions there are, the more interactions there are, the faster the solute will dissolve. Of these three, only the temperature also affects how much dissolves. The others only look at how fast. So temperature does affect how much dissolves.